Hi everyone and welcome to Miss B Maths Teacher channel. Today I'm going to talk about solving sine equations algebraically and using unit circle. So the one that you can see here on the side. So what we have given here is sine of x is equal to negative half, and x is in domain between 0 and 3 pi. So looking at this unit circle, if I start from here and I go around and stop there is just 1 pi. If I keep going and come back to the beginning, that is going to be 2 pi. I'm just going to add that here, so it's 2 pi. And if I'm going to keep moving, go one more time, then I'm going to have 1 more pi. So 2 pi's plus 1 pi is 3 pi's. So that's pretty much this, domain that we have to look. So sine x is equal to negative half. So we are looking for the value of x when sine of that x is equal to negative 1. So we already know that sine is y coordinate, and we can see here negative number, and y is negative here. So this is, y. It's negative in third and fourth quadrant. So I'm going to go like this. Third, fourth quadrant. This one is the first one and second one. So now all I'm going to do now is just to check where is negative half, and I can see it's here, negative half. So which means is the value of negative half, y equal to negative half. So if I go across and then across, yep. So another negative half, I can see that the value of x, or this angle, are equal to 7 pi over 6 and 11 pi over 6. So the first one is 7 pi over 6 and another one is 11 pi over 6. So we have 2, so it's in 2 pi. This is in, like 1 pi, 2 pi. And if I keep going, in 3 pi, we can see that we don't have any more solutions. However, sometimes we do have to check, for other solutions as well. And what we do, so usually we put here plus 2 pi k, and k is an integer. So, and the values of k that we may have a 0, plus, minus 1, plus, minus 2, etc. So when k was equal to 0, we had x equal to 7 pi over 6 and x equal to 11 pi over 6. When k is equal to 1, so what is happening here? So we let's have a look at this example here. Now we have sine of 2x is equal to negative half. So, and pretty much it's solved exactly the same way, only this time instead of x, we have two x's. So we're just going to go, okay, 2x equal to, and again, if you're looking, this is just our angle, okay, this angle. So, and if you're looking for what values of an angle, sine is going to be equal to negative half. So we're just going to do it like we have done before. So it's going to be this line going through y equal to negative 1. So negative 1 and negative 1. So the solutions for this one are 7 pi over 6 and 11 pi over 6. So 7 pi over 6 and 11 pi over 6. And as we have done before, so I'm going to put here plus 2 pi k. K is an integer. K can be 0, plus, minus 1, and etc. So, and we are using, substituting k, different values of k, because we may get the answer outside the required domain. Sometimes we're looking for, infinite solutions with our domain, and sometimes we're looking for the finite solutions with the domain, like we have now. So, because we have 2x now, here, 2x, what we're going to do, we need x, it's here. So, what we're going to do, we're going to multiply everything by half. So, you're going to multiply here, this side by half, and then as you remember, like in algebra, you have to multiply every single term by the same value. So we are multiplying every single term by half. So the first one on the left hand side, then this one on the right hand side, and this term as well. So this is going to give us going to cancel out. It's going to give us x is equal to multiplying this is going to be 7 pi over 12, and x equal to 11 pi over 12. So this one here is when k is equal to 0. So k is equal to 0. So, and this one is going to cancel out as well. So when k is equal to 0, when we substitute here, pi times k is 0. So therefore, we just have, those two solutions, this one here and this one there. Now, we do have to check different values of k. So when k is equal to 1, x is going to be equal to 7 pi over 12, and then plus k times 1, it's pi times 1 is pi, so it's plus pi. And when you simplify this or put them together, it will give you 19 pi over 12. And then x is equal to 11 pi over 12 plus pi. It will give you 23 pi over 12. So this is when k is equal to 1. Now what I'm going to do, I'm just going to check, those solutions and see if they are, within the required domain. So those two are definitely solutions, okay? So they are within 3 pi. 19 pi over 12 is less than 2 pi, so definitely solutions. 23 divided by 12, this one here. So it is definitely less than 2 pi, so therefore it is solution because it is within, required domain. Now, it does look like we have to check, the others. So what I'm going to do, I'm going to check for k equal to 2. So it's going to be x is equal 7 pi over 12 plus, when k is equal to 2, So this becomes 2 pi plus 2 pi, and it is equal to 7 pi 12 plus 2 pi. So I'm just going to do like this. 7 pi 12 plus 2 pi is the same as 24 pi over 12. So I have now the same denominator. So this is going to give me 31 pi over 12. And x is equal 11 pi over 12 plus 2 pi is equal to, let's do the same thing, 11 pi over 12 plus. And in case you're wondering what I'm doing here with this 2 pi, I'm just converting 2 pi into fraction, where I'm going to have denominator 12 so that I have the same denominator, which is just, again, 24 pi over 12, which is 2 pi. Okay, same as this one here. So this one and this one, they are exactly the same. And then equal to, same denominator, copy down, 11 pi, 24 pi is 35 pi. Now we're going to check the domain, and we're going to have a look. Okay, so what do we have? 31 pi divided by 12. It is definitely less than 3, because 3 times 12 is 36. So it is within domain. So this is our solution. And let's have a look at this one here. 35 divided by 12 close to 3 pi. So therefore it is within, and we're going to say this one is solution as well. As you can see, for this example, we do have 4 solutions. So I hope this helps, and I'll talk to you soon. Thank you for watching, and there's going to be solving sine equation algebraically part 2. Talk to you soon. Bye.